Alright guys, today we are going to be trying something different to look at these tutorials. We are going to be learning about the use of null models with Excel. The idea of null model is to compare if a sample, let's say a population of individuals, is significantly different from individuals from other populations. There are many different statistical tests that you can do, that you can use to compare where two samples are different from each other. Today we're going to be using specifically null models. The idea of a null model is that, let's imagine for instance that you take 1,000 trees from Hawaii and you want to find out if the trees from Hawaii are smaller than the trees from other parts of the world. In a null model, what you do is you take, let's say that you sample 1,000 trees here and you have the average body size of the trees here. The idea of the null model is that you collect randomly the body size of 1,000 trees from other places around the world, and then you compare how different those two populations are. Obviously, because you had done that only once, there is a chance that the random sample that you took was weird, so you might find significant differences there that might not be real. So with the null model, the idea there is that you need to replicate this random collection of samples from around the world a few thousand times until you are confident that you had a good sense on how variable are the body sizes from trees from around the world, and then you compare that to your trees. As a result, you can find out how different your trees are. Let's look at an example, and maybe from that we will understand better. Today we're going to be using some databases looking at the patterns of species richness, basically how many species are on a specific place. Specifically, we're going to be looking at reef fish. If you look at the distribution of reef fish, this is for instance one of the papers that describe that. If you look at the distribution of reef fishes, what you find is that in the entire world, the largest diversity of fishes is found here in this region that is called the Indo-Pacific, right there, right? You move away from that center towards the Indian Ocean or towards the Pacific, the number of species declines. Now, if you look at the Atlantic, the greatest diversity of fishes is found in the Caribbean, and very few places had more species than that. So one of the first papers looking at this pattern was a famous paper by David Bellwood and Terry Hughes, who are professors at the University of James Cook in Australia. What they did, they went to all of these locations. Well, they actually took the data from the internet, publications from all of these places, and they took the list of species from every one of those places. Then what they did was to count how many species had been reported on those specific places, and what they did is they compared the proportion of species within certain families against the total number of species on those locations. Basically what they found is that independent of whether you had 10 species, like in this case, or 600 species, like in this case, the proportion of species within these families around it is the same. This was, of course, a massive discovery because it suggests that ecological interactions don't really have a strong effect on the diversity of local assemblages. Because the places have so many different species, you will expect that if ecological interactions are having an important role on communities, then those proportions will be very different. There has been some discussion about what this really means, but let's just leave it there for now. What we're going to be doing today is just trying to replicate one of these figures. Let's just specifically look at this family, for instance. So what I did as part of my PhD, I actually went and collected all of this data by myself again. And this data has been set this up here. This data has been used in many different papers. Originally, the database was used on this paper in Science. It was then used in this paper in ecology letters, this other paper in ecology, this other paper by Sean Connolly in the American Naturalist. So what I did was to collect all of this data myself, and I actually ended up publishing some of my own papers here in the journal Nature. So you're gonna get this database with this tutorial. And let's get started. So the database is pretty simple. Basically, you had this, every row here is a species of fish. This is the family of that species. And here you have all of the locations that exist, the Red Sea, the Western Arabian Gulf. And we had about 70 locations from which we collected all of the species that had been reported on those places. Let's do some quick organization of the database. Let's organize first so that this becomes more visible. Let's make all of these locations lining up on the top. So for that, select all of the rows, format cell. Here you had alignment. We're gonna make all of that text to align vertically. That way we can see the locations better in our screen. All right. So again, if you look at, let's minimize this one here. So if you look at this database, again on column C, you have all of the species, and in row 1, you have all of the locations where those species are found. So here, for instance, this one indicates that this species is found in the Red Sea. It's also found in Reunion Island. And here are all of the locations where this species is found. Wherever there is an empty cell, that means that the species is not found there, right? So the purpose of this tutorial is to replicate Bellwood's hypothesis, is to find out what is the proportion of species in the family Serranids. So if you scroll down, you see all of the families there. Sorry, before we start there, let's fix the top row so that it doesn't move, right? So for that, you click on the cell, A2, go to view, freeze, and here you have an option to freeze different rows of your screen, right? We are gonna freeze right now just the top row so that it stays quiet as we scroll down. So as you can see now, the first row stays quiet while you move down your database. So we're going to scroll down to look for the family Serranids, right? So the family Serranids is found here. This is that right there. So the family Serrani goes from row 1685 all up to the last row, right? So what we want to do is to count the number of species of Serranids, for instance, in the Red Sea. For that, we come to cell H1974 and we type equal sum. We are gonna sum from the first row, the last row where the Serranids are found, all the way up to the first row where the first species of the family Serranid is found, right there. Oopsie. So the first family the first species of the family Serranid, as you can see, is in row 1685. And you can see here, we are summing all of the species, all of the records from the family Serranid from cell 1685 all the way up to the last row. You close your brackets, you click enter. So for instance here, in the Red Sea, the family Serranid has 23 species. let's type here a species by location. Right? Now, obviously we want to calculate the total number of species. Let's put it here. In the whole location. And for that, we are just gonna sum from the last row for the Red Sea all the way up to the first row. Right. So basically, you look at the equation here, is the sum between cell H2, sorry, H4, right? Actually, you can see that it gets highlighted there. So the first species in the family in the Red Sea is in cell H4, and the last one is in H70, 1973. So here basically what you find is that the total number of species in the Red Sea is 209 species, of which 3 species are from the family Serranids. Actually, let's change these to species, Serranid species, right? So these are the total number of species in the family Serranids, and these are the total number of species in that location. Now the proportion is just dividing 23 by 2009. Right? So basically you type in this cell H 1976, you type equal this cell divided by this cell. So basically the proportion of Serranids in the Red Sea is 10%, right? 0.1, because this is a proportion there. So now we want to do this for all of the other locations. So what you do, you select these 3 rows, you click in this black button, click on it, and then you move it to your right until your last location, which is Korea. So in Korea, the number of species in the family Serranid is 25. There are 127 species there, and the proportion is about 20% of them are Serranids. So let's look quickly, let's just do a correlation there, a plot between the total number of species and the proportion of species in the family Serranids. So you select the 2 rows that we want to plot, total number of species and their proportion. You go to insert, scatter, and then we just do a plot there. So here again, you can see in the y-axis is the total number of species. Sorry, in the x-axis is the total number of species, and on the y-axis is the proportion of species in the family Serranids. Now we just move that to the side, and we look at the paper by Bellwood here. One thing that you can observe from this is hard stuff. There. This is the famous paper by Bellwood right there. And this is our figure, right? This is for the family Serranids. And you can see that the figure is pretty much the same. Again, roughly to about 35%. And it goes all the way up to about 600 and something species. Now, one of the things, of course, that is missing from this is the fact that we're still missing the null model, right? How different is this pattern from a random pattern, right? And that, of course, is what they did here with these black lines. These black lines is the expected proportion of a species if you were to select a random number of species from these oceans. So let's replicate that null model. Again, the idea is to find out how different is this pattern in which the proportion of a species is relatively stable regardless of how many species are there. So obviously what we want to do is a null model, and in this null model we want to replicate a random selection of about 23 species from every one of these locations, and we want to do that, let's say, 1,000 times, right? So what we are going to do, the first thing is we are going to copy this actual value. You select all of the cells that were calculated, you copy this, and you are going to paste it on cell G1979, right click on it, paste special as values, right? We are going to rename this, and this is the actual proportion, right, of serranides. This thing a little bit broader here. And now, how do we calculate now the proportion of a species should we select randomly 23 species, right? For that, we are going to run the null model, go to the top. We are going to call this column here, we're going to call it random order, random. And what we are going to do, we are going to enter a random number. And random numbers in Excel is the function equal ran, close bracket, open brackets. So when you click on that, Excel will give you a random number between 0 and 1. Every time that you do a modification on your Excel sheet, that number gets recalculated, right? You can see how the number changes even without me modifying it. So what it means is that I will give a random number to this species, right? And I want to do that for all of the other species. One way to do it is for me to click on that corner, that black square there, scroll down, or I just double click on it. If you double click on it, the function is copying all the way up to the last row, right? Here you just remove these last three. Basically here you can see that the function random is applied to that cell as well. Now, what we want to do here is to shuffle these assemblages. Right now the database is organized by family, but if I select this row, then I push Shift Control arrow up, and I go up to the first species, right? Now I go to data, and I sort, but I'm gonna sort this by column B, right? So basically I'm sorting my database now by that random number. So one of the things that happens there, as you can see now, is that the families are all randomly selected. But here, on this number, on this function that you applied before, the number of species that were originally for serranids in the Red Sea still remains the same. So basically what you are doing now is counting for the Red Sea, how many species will there be randomly. Should you select the same number of species in the family serranid, right? So in this case, those proportions are very similar for the Red Sea, but you can see here, for instance, that now for the Western Arabian Gulf, the proportion now of serranid is 20%. So basically, if you were to select the same number of species in the Western Arabian Gulf, which are 8 species, by chance alone, only about 20% of them will be serranids, right? Originally, the proportion was only 10%. So obviously you can see that for the Western Arabian Gulf, the diversity of serranids is usually smaller than what you expect by chance. Now what we want to do is to replicate this 1,000 times. So for that we're going to do a null model. So you go to developer, record new macro, macro 1. Okay, so what we are going to do here is we are going to select again, we're going to repeat what we just did. Select the last row of our database, then you push shift control arrow up. That will take you all the way up to the first row. The next thing that we do, we go to data, and then we sort this by column B. Then we click OK. That changes the proportions. So we're going to copy the entire row where the proportions were just calculated. We copy that, and now we're going to paste it right here on this row, right? A row below. Let's maybe just do a space, maybe 5 rows below the actual proportion. So what we had done there is an interaction of this random selection once. So this is like running the null model once. So now you stop the macro by clicking here. Now you delete this. We can check out if our macro actually did the work. You come back to developer, look at macros, you look at our macro 1, you run it. See, you can actually see there very quickly what it did. It did exactly the random selection, the random organization. It copied your proportions and then it pastes that value here. Now what we want to do is to replicate this 1,000 times. So how do we do this? We go back to developer, we click on macros. You see your macro there, the one that was just recorded, and then you click edit, right? That will take you to Visual Basic, and it will tell you all of the things that we did there. So let's read quickly over this. What was the first thing that we did? We selected the entire row 1973. You can see there being selected, row 1973. Then we use selection arrow up. Then we selected that. This scroll down 6. That's just the movement of the mouse. So we can delete that because we don't really want to move the mouse. I mean, that's everything that you do gets recorded. This pretty much is the code for you to move the mouse 6 times lower. Now here you go into the thing that is sorting up. It's gonna sort out. This is all sorting. Here on this row, now we selected the row 1976, which is again here what you can see where our proportions are calculated. Then we copy that selection. Now we move to row 1985 that you can see there, and then we paste that as value that explains this, right? So that's our macro there. You can run it again from here just for you to see what it does. Right there, that just was one interaction. Obviously what we want to do now is to repeat this 1,000 times. Here is where Visual Basic becomes very useful. So you go to the top of this code and type for a equals 1 to 10. Let's just run the simulation 10 times. So here, what do you want to do? You want to, again, sort out your database. We're not going to do nothing new there. Then we select our row where the calculation is done. We copy that. But what we want to offset here is this place where we paste the results or the recalculation of the calculation, right? So here we're going to type selection.offset. We are going to offset this by 0 rows and 0 columns and 8 rows dot select. We have used this before, so I'm not going to go into much detail about this. And here we're going to tell it go to next A, right? So what did we did there? Basically we copy an entire row once, which is this one here. We copy it, we then selected the row, and then we are going to offset that selection by whatever times we do it. So if we run this, of course there is an error. Let's find out what the error is. There is an error here, so that's because I'm offsetting by 0 columns. So actually what we need to do here is to modify this A to 0. Again, if you remember, when you are offsetting, you can offset by this number of rows and this number of columns. I made a mistake there, it was the other way around. So I pause this, and now I can run it again. And there it goes. Our null model replicated 10 times. So this is a random proportion of species of 23 species for the Red Sea. Now what we want to do, now that we know that our null model works, is let's run this for 1,000 times. Let's do it just 100 times for the sake of running the tutorial quickly, but you should do it for 1,000 times and then you run it. It's gonna take you a couple minutes. You can see there the null model making all of your calculations for you. All right, that's it. It did finish already. So we had about 100 random selections. Now what we want to do is, let's select the lower percentile, which is again, and the upper percentile. And that's calculated with a function that is called percentile. You open brackets, you select your array. Basically, it goes from the first row of your simulations all the way up to your last row. K is the tail that you want to calculate. I mean, what is the lower margin? So we're going to type 0.05. So basically, that will give you, of all of the 100 observations that you just did there, what is the lower 5% of them, right? That's 0.1. So this is exactly the same. But now for the upper percentile, and let's select the 95 percentile, and that's usually with the function 0.095, right? And then you click enter. So there you have it. So this is the lower, randomly, of those 100 samples that you did. On average, the 5% for all of those observations is 10%, and the upper 95% is 20%, right? So we do that calculation for all of the other locations. So you select those 2 rows there, and then you scroll to the right, your selection, until the last location, and that calculates for you the proportion of species at every one of those locations, right? So now what we want to do is to add those data into our figure. So you select the figure, right click on it, click on select data. Now we want to add a new series, so you click add. Now the X is going to be the total number of species, which goes from cell H 1975. Then you push Shift Control arrow to the right. That will select the last cell. Now we want to select the Y's, which is the lower percentile. So you select this row, this cell here, BY 1981. Then you push Shift Control arrow to the left, -1, and that will select all of your data for displaying on your figure there. Now let's click OK just to be sure that this is doing the right thing. So you can see the lower percentile being there. We can change this. This is now as points. So if you select on the figure on your points, you can right click on it. You can click change time series, and you can select this option here, which is lines. Click OK, and that will give you some lines there. Maybe not. Let's just undo that. Let's add up now the upper percentile. We do the same thing. Here you click on the figure, right click on it, then select data. Now we are going to add another series. We are going to name it upper 95 percentile. Again, the x-axis is the number of species. You select that cell there, then Shift Control arrow to the right, click enter. That will select all of the data that you want to show in the x-axis. Now let's select the data for the y-axis. You click in here, go back there, and now we want to select the upper percentile. So you select the first cell where the data is located, then you push Shift Control arrow to the right. That will select all of the data that you want to display in the y-axis. So click OK. You click OK, and now if we look at our figure there, so you look at our figure here, you can see that the abundance, sorry, not the abundance, the density of serranids on all of these places in the world are within the confidence limits of what you expect to see by chance, right? And if you look again at the figure by David Bellwood, there, you can see that our figure, this one here, is very similar to this figure. And this is how Visual Basic can be used to test hypotheses and generate null models. Note that if we were to have done this in 2001, when this paper was published, we could have got this simple analysis in the journal Science. And that right there is one of the ways to use null models in Visual Basic. Anyway, I hope this is a much better way to do these tutorials. See you in class next Monday.